Okay, so if we're looking at a 3-digit number, we have to have placeholders for the digit. So you can have, let's just say that our 3-digit number happens to be A, B, C. That is not multiplication between them, though. That is saying, like, if A is 1, B is 4, and C is 7, 147. Yeah.
So I'm confused when you said if sum of that is 15. Is it like...
So the sum of a 3-digit number is saying, like, the sum of the 3 digits. So in other words, my first equation is going to be A plus B plus C. Okay. If I take the sums of those digits, that's going to add to 15. Okay. Now the second part is where things get tricky. So don't write this, just watch. A lot of you are going to be tempted to say, okay, ABC equals CBA, and what did I say it was? It was 59 times more. So actually I've got that. A lot of you are going to want to write CBA equals the original plus 59. Why is that not okay? C is saying a number, right? B is a number, A is a number. If you write the equation like that, what operation is happening between C, B, A in equation form? It'd be multiplication. So like if you write it like this, let's say that C is 1 and B is 4 and A is 7, like I said. This equation is going to do 1 times 4 times 7. That's not what you want it to do, though. You want it to be 147, not 28. Do you see what I'm saying? Okay, so you can't just write the digits in order in equation form, because in equation form, it's going to multiply. So the way that you handle this is, let's say that I want to write what the number is reversed. Okay? The number reversed puts the C in the 100 spot, right? So that looks like 100 times C. That will give me, like, if C is 3, I want 300, right? So 100 times 3 will give me the 100 spot. Plus, and if I add 10 times B, that gives me the 10 spot, and then I can add C for the single spot. Or, I'm sorry, A. I want A right there. So again, let's just kind of look through. I'm just going to pick a random number and use it as an example. If my number is 567, and I need to write that out in terms of 5, 6, and 7, if I do 500 plus 60 plus 7, that gives me the number itself, right? But in terms of computations. So that's all that I'm doing up here is taking the 100 spots for the C, so 5 times 100, 6 times 10, and then just your single spot. That's the trick to this one, is that you have to write the equation in that form if you're reversing the digits. Okay? All right, so now let's just work with the equation that we've actually got. All right, so that is the digit reversed. I want that to equal the original number, which will be 100 times A plus 10 times B plus C. So that's the number in its original form. The only thing that switched there are the C and the A came here, reverse it, A and the C comes first. And we're saying that this number here should be 59 times more than this. So plus 59. Are there any questions on that? Okay. And then it says that the sum of the first and second digits, so the sum of the first and second digits would be A plus C. And I am saying that that should be 3 less than what the third digit is. So, first and second would be A and B, C minus 3. Any questions on that part? Okay. So at this point, I want to start solving this. What can I do? Sure. So on this last equation, she's trying to isolate a variable. So on this last equation, she's going to isolate C, right? So she is saying, all right, let's do C equals A plus B plus add that 3 over will give me C. And that's what I can plug into this equation. And I'm going to be able to plug it into the second equation, but can I simplify things up here so that I don't have to deal with such big numbers? Yes, right? So on that equation, what I can do is notice that the 10b's on either side are going to cancel when I subtract 10b. All right, let's move the c's over. So, and I'm just going to squeeze it in below here. If I take this c and subtract it off of 100 c's, I have 99c. If I have this a and I subtract off 100a, I have minus 99a. And then I'm just going to leave my 59 on the other side for right now. Make sense? Okay, so I am no longer using this equation. I'm using the simplified version of it below, right? Okay, so like we just said, we had solved for C here in this equation, so now I need to plug it into the other two. So I need to plug it into this equation right here, and I need to plug it into this equation right here. Okay? So, I'm kind of running out of space here, but let's see what I can do. That is going to give me, on the top equation, I'm going to have A plus B plus, and now I'm plugging in all of this stuff for C, right? So plus A plus B plus 3. Oops, I'm sorry. I'm not on top of it today. That's not where my C is. Plus, oh wait, no, it is. I'm sorry. I'm losing my mind. A plus B plus 3 equals 15, right? All right. And now I'm going to plug into, where am I? The blue equation, so this equation right here for that C. So I'll have 99 times this stuff for C again, A plus B plus 3, and then minus 99A equals 59. Yeah, I can jump back and hit that. Okay, I need to figure out how to make this screen from stop doing that. Is it up right now? Okay. All right, so I need to simplify some of these equations. So that first purple equation is going to become, and I'm going to try and squeeze it in off to the right here. That first equation is going to become 2a plus 2b equals 12. Any questions on how I got that? From, where's my arrow? From this guy? 2a plus 2b, subtract my 3 to get 12. Okay, now let's think through this next equation. You're going to be distributing the 99 in, right? But then you've got minus 99. So what's going to happen with your a's? A's are going to cancel, right? And then you're going to have 99b. What's 3 times 99?
297.
Okay, what's 59 minus 297? Negative? Yep. So what are we saying that B equals? Divide by 99, what do you get? Nothing good, right? What is it? Let's talk about it.
Negative 2.404040.
So we'll just do negative 2.4 about. Why is that bad?
You can't have a negative digit within a number.
I can't have a negative digit, first of all, right? A digit should be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay? So first bad thing is that there's a negative. Second bad thing is that there is a decimals, also bad. So for this one, you would want to recognize not possible. The number doesn't exist. And that can be written as DNE. So it is possible to have that I'll give you something that doesn't quite work, and I would want you to be able to see, you know, hey, that's not going to work out. That's not a possibility for this particular problem. Okay? The main thing is that we need to be able to do that setup, and the trickiest part to the setup of this was just doing this whole 100s, 10s, singles digit when you want to reverse the digits. Right? So I apologize for having miswritten that. The way I wrote it with the sum on that second part would have made it not make any sense whatsoever. So at least now it makes sense. Okay, we've got another type of problem here, and give me 1 second to scroll down. Okay, so this problem is actually quite a bit easier than the last problem as far as the setup. So if I give you something like this where I give you 3 x, y values, so it could be written in a word problem like this, or it might just be that I give you an input x with an output y, input x with an output y, input x with an output y. Right? All right, so the main thing is that if I don't give it to you in coordinate form already, you'll want to write it in coordinate form. So what are the 3 coordinates that you get out of that table? You get 0, 0, comma, that's your x value. What's your y value? Yep, you get that. You get 7, 9. And you get 20, 21. All right, and you want to be using the fact that this is an x, y coordinate situation. So all that you have to do to set your equations up for this is use this equation right here. And the plus c kind of got bumped down, but f of x or y equals ax squared plus bx plus c with each respective xy coordinate. So you'll get one equation off of this coordinate, another equation off of this, and a third equation off of this. Right? So let's see what that looks like. For the first equation, oops, it's pretty nice that we've got a 0 for x, because if I plug 0 for x into that equation, you get a times 0 squared, that's my x value, plus b times 0, plus c, and that equals your y value, which in this case is 16, right? The fact that that x value is 0 is really nice because it cancels out. That won't always happen. In this case it did, which makes our solving quite a bit nicer, because I get that c is equal to 16. I've already solved for one of my variables, right? Okay, your second equation is very similar, except for now you're using the second point, so your x value is 7. So you'll be plugging in a times 7 squared, that's your x squared, plus b times 7 plus c, but what do we know that c is overall? So I can just put 16 in now and use it. That's going to equal 9. I'll go ahead and clean that equation up. So 7 squared is, so I get 49a plus 7b, and then if I subtract the 16 over, I get 9 minus 16 is negative 7. Very good. And I've got one more equation to write. So my next equation is going to be a times 20 squared plus b times 20 plus c, which is 16, equals 21. That simplifies down to 400a plus 20b equals 21 minus 16 is 5. One thing I'm going to notice on this last equation is that I've got big numbers. Can I kind of simplify all those? Yeah, I can divide the entire equation by 5 and I'll get even numbers, right? So I would do that just to kind of, if you can, keep your numbers simpler. So if I divide 400 by 5, I get... So this is actually 80A plus 4B equals 1, right? So that might help us on our next steps. Now we've got two equations of two variables. Here's one of them in terms of A and B. Here's the other in terms of A and B. Solve those however you want. You already know what C is, so you just have to find A and B at this point. Substitution or elimination, which one do you guys want? Doesn't matter, just pick one.
You could do substitution pretty easily if you solve for the other equation.
I'm even looking at the top equation maybe. No, well, yeah. The top equation might be better because down here, whoa, if I solve for A or B, I'm going to end up with a fraction when I divide 1, right? Up here though, like let's say I solve for B up here, I'll be able to divide everything by 7 and it won't give me a fraction, right? So I'm going to kind of work on that top equation for substitution. All right, so I'm working on this guy right here. I'm going to solve for B. If I solve for B, I'm going to start out by subtracting my 49. So I'm going to have negative 7 minus 40, or I'm sorry, yeah, minus 49A. And then divide everything by 7. I get B equals a nice even negative 1 minus 7A. And now I just want to take that and plug it into this B right here. All right. So if I do that, I'm going to have 80A plus 4 times my B value, which is negative 1 minus 7A, equals 1. So that gives me 80A minus 4 minus 28A equals 1. What's 80 minus 28? 52. If I add my 4 over, I get 5, right? So A equals 5 over 52. Am I still on the screen? Oh, that Go Siri thing is up there. Hold on. Okay. Can I find B pretty easily now? Right here, right? So I'm going to pick another color so I don't lose myself. This is going to be negative 1 minus 7 times my A value, which is 5 over 52. It's okay that you guys are getting fractions. Go ahead and just deal with them. Okay, so this is, I'm going to kind of squeeze it in down here, negative 1 minus 35 over 52. But I would like that to be one big number. So how could I rewrite 1 in terms of 52? I can write 52 over 52 for 1, right? So what's negative 52 minus 35? Yep, negative 87 over 52 is B. So the last thing that we have to do, because the problem is actually asking us to fit a quadratic function into this form, so we just want to take our A, B, and C value and write it as an equation for our last step. Okay, so what that looks like is f of x equals our A value, which was 5 over 52, x squared, plus our B value, which is negative 87 over 52, x, plus our C value, which is 16. Oh, that didn't show up at all. where I thought it was going to. Sorry. Let me actually rewrite that where you guys can actually see it. I thought I was in a completely different spot on the screen. All right. So we had f of x equals your a value, which was 5 over 52 x squared, minus your b value is 87 over 52 x, plus 16 for c. So that would be your equation. Any questions on that one? No? All right.